দেখো লেকচার নাম্বার 1 ম্যাট্রিক্স অ্যালজেব্রা। লেকচার নাম্বার 1-এ ম্যাট্রিক্স অ্যালজেব্রাতে আমরা অ্যাকচুয়ালি বিভিন্ন টাইপের যে ডিফারেন্ট টাইপসের যে ম্যাট্রিক্স ছিল এগুলো আমরা পড়েছি আগের দিন। তো সেগুলোকে আবার ডিটেলস ডিসকাস করবো একটুক্ষণ পরে সেগুলোকে আবার ডিটেলস ডিসকাশানস করব। তো আজকে সবার প্রথমে আমরা ম্যাট্রিক্সের আইগেন ভ্যালু এক নম্বর যেটা আমরা জানবো সেটা হচ্ছে ম্যাট্রিক্স রিপ্রেজেন্টেশনস। ম্যাট্রিক্স রিপ্রেজেন্টেশন সম্পর্কে জানবো। 2 নম্বরে জানবো হাউ টু ক্যালকুলেট আইগেন ভ্যালু অফ ম্যাট্রিক্স। 3 নম্বর ক্যালকুলেট করব হাউ টু ক্যালকুলেট eigenvector of a matrix. Next আমরা পড়ব Cayley-Hamiltonian theorem. That is very important. Cayley-Hamilton theorem. এই Cayley-Hamiltonian theorem থেকে আমরা অ্যাকচুয়ালি ক্যালকুলেট করতে চলেছি ইনভার্স অফ এ ম্যাট্রিক্স। Cayley-Hamiltonian theorem থেকে আমরা অ্যাকচুয়ালি ক্যালকুলেট করতে চলেছি ইনভার্স অফ এ ম্যাট্রিক্স। একটা ম্যাট্রিক্সের ইনভার্স ক্যালকুলেট করব, দ্যাট ইজ ভেরি ইম্পর্ট্যান্ট। Cayley-Hamiltonian theorem এক্সামের দিক থেকে দেখতে গেলে এই থিওরিটা প্রচণ্ড ইম্পর্ট্যান্ট একটা থিওরি। তো আজকে আমরা এই 4খানা টপিক অ্যাকচুয়ালি এখানে মেনলি ডিসকাস করব। ম্যাট্রিক্স রিপ্রেজেন্টেশনস কেমন করে করব এবং হাউ টু ক্যালকুলেট আইগেন ভ্যালু অফ এ ম্যাট্রিক্স অ্যান্ড হাউ টু ক্যালকুলেট আইগেন ভেক্টর অফ এ ম্যাট্রিক্স অ্যান্ড দেন ক্যালকুলেট inverse of a matrix using Cayley-Hamiltonian theorem. These 4 topics are very important. We are discuss now. Okay. So first of all, how to represent a matrix? Representations of a matrix. Okay. Representations of a matrix. রিপ্রেজেন্টেশনস অফ এ ম্যাট্রিক্স, একটা ম্যাট্রিক্সকে আমরা কেমন করে রিপ্রেজেন্ট করব, অ্যাকচুয়ালি রিপ্রেজেন্ট করব। এ ম্যাট্রিক্স is mainly consist of row element elements along row elements as well as column element ওকে। কলাম এলিমেন্ট, একটা ম্যাট্রিক্স রো এলিমেন্ট এবং কলাম এলিমেন্ট নিয়ে অ্যাকচুয়ালি সেটা তৈরি হয়, মানে সেটাকে আমরা লিখতে পারি একটা ম্যাট্রিক্সের রিপ্রেজেন্টেশনটা। তো এখন যদি আমরা ধরে নেই যে একটা ম্যাট্রিক্স অ্যান্ড ইট ক্যান বি রিপ্রেজেন্টেড as like that A11, A12, A13 and so on A1n. Similarly A21, A22 and so on A23 and so on A2n and so on AN1, AN2, AN3 and so on ANn. This is the matrix representations. এখানে ভালো করে যদি আমরা অবজার্ভ করে দেখি এখানে যদি আমরা ভালো করে অবজার্ভ করে দেখি, রো বরাবর এনটা এলিমেন্ট আছে, কলাম বরাবরও এনটা এলিমেন্ট আছে, তাই না? এই ম্যাট্রিক্সটার ক্ষেত্রে যদি আমরা অবজার্ভ করে দেখি, এখানে রো বরাবরও এনটা এলিমেন্টস আছে, কলাম বরাবরও এনটা এলিমেন্টস আছে। দ্যাটস ওয়াই দিস ম্যাট্রিক্স ইজ কল্ড n cross n matrix. That's why it is called n cross n matrix. First n represent number of column, second n represent number of row. Okay, this is the matrix representations, and this matrix have a this elements and this diagonal elements are called not 2 3 is not a diagonal element, এখানে কোন একটা এলিমেন্ট হবে সেইটা, যাই হোক a 2 3টা ডায়াগোনাল এলিমেন্ট নয়, ডায়াগোনাল এলিমেন্ট। যদি আমরা একটা 3 cross 3 ম্যাট্রিক্সই নেই তাহলে আর ভালো করে ব্যাপারটা বুঝতে সুবিধা হবে। তো অ্যাজিউম এ 3 cross 3 ম্যাট্রিক্স, a matrix 3 cross 3 matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a 3 cross 3 matrix. This is a 3 cross 3 matrix, and this 3 cross 3 matrix have a A11, A12, and A33. These elements are called principal diagonal element. Principal diagonal elements. Here A11, A22, and A33 are called principal diagonal element. Okay, principal diagonal element. These three elements are called principal diagonal elements, and except these three elements, other elements are called off diagonal element. Off diagonal element, and except these elements, rest elements are called off diagonal element. Off diagonal elements. Okay, these three elements, এই তিনটে এলিমেন্টকে যদি আমরা বাদ দিই, তিনটে এলিমেন্টকে বাদে বাকি এলিমেন্টগুলোকে আমরা বলবো অফ ডায়াগোনাল এলিমেন্ট। বাকি এলিমেন্টগুলোকে আমরা বলবো অফ ডায়াগোনাল এলিমেন্ট। ওকে, অফ ডায়াগোনাল এলিমেন্ট আমরা এগুলোকে বলবো। নেক্সট আমরা ক্যালকুলেট করব হাউ টু ক্যালকুলেট আইগেন ভ্যালু of a matrix. How to calculate eigenvalue of a matrix. Okay, how to calculate eigenvalue of a matrix. আমরা একটা ম্যাট্রিক্সের আইগেন ভ্যালু কেমন করে ক্যালকুলেট করব, সেটা তোমার কাছে 3 cross 3 ম্যাট্রিক্সও হতে পারে, সেটা তোমার কাছে 2 cross 2 ম্যাট্রিক্সও হতে পারে, আবার 4 cross 4 ম্যাট্রিক্সও হতে পারে। ওকে, যে কোনো অর্ডারের ম্যাট্রিক্স সেটা হতে পারে, যে কোনো অর্ডারের ম্যাট্রিক্স সেটা হতে পারে, যে কোনো অর্ডারের ম্যাট্রিক্স হতে পারে, যে কোনো অর্ডারের ম্যাট্রিক্স হতে পারে। হেডিং দাও, হাউ টু ক্যালকুলেট আইগেন ভ্যালু of a matrix. How to calculate eigenvalue of a matrix. How to calculate eigenvalue অফ এ ম্যাট্রিক্স। একটা ম্যাট্রিক্সের আমরা আইগেন ভ্যালু কেমন করে ক্যালকুলেট করব, একটা ম্যাট্রিক্সের আমরা আইগেন ভ্যালু কেমন করে ক্যালকুলেট করব। লেট আস কনসিডার ম্যাট্রিক্স A11, A12, A13, A21, A22, A23, A31, A32, A33. This is nothing but a 3 cross 3 matrix. তো আমরা যদি এই 3 cross 3 ম্যাট্রিক্সটার আইগেন ভ্যালু ক্যালকুলেট করতে চাই, হাউ ক্যান আই ক্যালকুলেট? So for calculations, calculations of eigenvalue, calculations of eigenvalue of matrix A, we use characteristics equations. We use characteristics equations of matrix A. Okay, of matrix A, of matrix A. আমরা কোনো একটা ম্যাট্রিক্সে যদি আইগেন ভ্যালু ক্যালকুলেট করতে চাই, তাহলে আমরা কি ইউজ করব? ক্যারেক্টারিস্টিক্স ইকুয়েশনস অফ ম্যাট্রিক্স এ। উই ইউজ characteristics equations of matrix A. So what is the characteristics equations? Now characteristics equations actually কি হবে না, determinant of a minus lambda I equals to 0. Determinant of a minus lambda I equals to 0. Where lambda eigenvalues of matrix A. আমরা এই ল্যামডার মানটা অ্যাকচুয়ালি ক্যালকুলেট করব এখানে। eigenvalues of matrix A. ওকে, তিনটা ভ্যালু আসতে পারে। যদি 3 cross 3 ম্যাট্রিক্স, তাহলে তিনটে ভ্যালু আসবে এখানে, তিনটে ভ্যালু আসবে। eigenvalues of matrix A. I is called a unitary identity matrix and identity matrix of 3 cross 3. যেহেতু তোমাকে ম্যাট্রিক্সটা যেই অর্ডারে দেওয়া থাকবে সেই অর্ডারের ওটা একটা আইডেন্টিটি ম্যাট্রিক্স হবে। এ ম্যাট্রিক্স যদি 2 cross 2 ম্যাট্রিক্স হয়, তাহলে আইটা 2 cross 2 ম্যাট্রিক্স হবে। যদি ওটা 3 cross 3 হয়, তাহলে আইটা 3 cross 3 হবে। রেসপেক্টিভ অর্ডার, মানে এ যে অর্ডারের ম্যাট্রিক্স হবে সেটা আইটাও সেই অর্ডারেরই হবে। যেহেতু এখানে এটাকে আমরা 3 cross 3 ধরেছিলাম, তাই এখানটায় আমরা মেনশন করলাম I is an identity matrix of 3 cross 3. Okay, so now this is a determinant form. It means determinant of A minus lambda I determinant equals to 0. Okay, so determinant of A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33 minus lambda is a constant value. It's take outside the determinant, and determinant of I is nothing but 1 0 0 0 1 0 0 0 1. Determinant is equals to 0. Okay. So now that is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33 minus determinant of lambda 0 0 0 lambda 0 0 0 lambda equals to 0. Okay. So now we perform simple subtractions between two determinant. Very easy. That is equals to determinant of a11 minus lambda a12 a13 equals to a21 a22 minus lambda a23 a31 a32 a33 minus lambda. This is the equations. So after writing these equations, is it clear? So after writing these equations, we are directly write the determinant form of matrix. Okay. After writing these equations, we are directly write these equations. Only lambda is subtract from the diagonal element of a matrix. Only lambda is subtract from diagonal element, and then we perform some mathematical algebra and find out the value of lambda. Okay. Okay. So how can I find out the value of lambda? So now we have performed some mathematical expressions for determinant that is equals to a11 minus lambda is equals to a22 minus lambda a33 minus lambda minus, not minus, is it plus a12 is equals to a23 into a31 minus a21 into minus a21 into a33 minus lambda plus a13 is equals to a21 into a32 minus a22 minus lambda into a31 is equals to 0. Right? This is some basic mathematical algebra. Okay. So in this way we can find out the value of lambda. That means it means eigenvalue of a matrix. Okay, eigenvalue of a matrix. So first of all, we take a very simple example, 2 cross 2 matrix, and then we take a 3 cross 3 matrix, and then we take some difficult problem, how to calculate the eigenvalue of a matrix. Okay. Okay. First of all, we take some simple example, very simple example. Okay. Find out the eigenvalue of a matrix. Find out the eigenvalue of a matrix. Let us take a very simple example. Okay. Let us take very simple example. Example number 1. Here I have a matrix. Here a matrix 1 2. Find out the eigenvalue of a matrix. Find out the eigenvalue of a matrix. Matrix elements are 1 2 2 minus 1. 2 minus 1. This is an 2 cross 2 matrix. Okay. So for this 2 cross 2 matrix, we are find out the eigenvalue of a matrix. So find out the eigenvalue of a matrix A. We use characteristics equations of matrix. Okay. So now the characteristics equations. Now characteristics equations of matrix A equal each matrix A each A minus lambda I equals to 0. A minus lambda I, it means lambda is a subtract from only diagonal elements, right? So it is equals to 1 minus lambda to 2 minus 1 minus lambda is equals to 0. This is the ultimate form of determinant of a minus lambda I. This is the ultimate form. Okay, this is the ultimate form. Is it clear? So now next step is we perform very basic mathematical algebra to find out the value of lambda, find a very basic algebra of determinant 1 minus lambda into minus 1 plus lambda minus 4 is equals to 0. That is equals to minus of 1 minus lambda 1 plus lambda minus 4 equals to 0. That is equals to 1 minus lambda square equals to plus 4. 1 minus lambda square equals to minus 4. 1 minus lambda square equals to minus 4. Okay. So now this is equals to lambda square minus 1 equals to plus 4, lambda square equals to plus 5, lambda equals to plus minus root 5. So for 2 cross 2 matrix we get 2 eigenvalues. One is lambda plus root 5, another is minus root 5. If this matrix is 3 cross 3 matrix, then we get 3 eigenvalues. Okay, so eigenvalues are lambda 1 equals to plus root 5, minus 1 equals to minus root 5. Okay, minus lambda 2 equals to minus root 5. So if the matrix is 2 cross 2 matrix, we get 2 eigenvalue, and if the matrix is 3 cross 3 matrix, we get 3 eigenvalues, and if the matrix is 4 cross 4 matrix, it means 4 eigenvalues. It means these 2 are root of the linear equations, roots of linear equations. So what are the linear equations? A matrix can be formed from a linear equations, right? Let us consider 2 linear equations. Let us consider 2 linear equations. 2 linear equations. Okay, linear equations. 5x1 6x2 equals to 3, and 4x1 plus 7x2 equals to 8. So if we solve these equations, we get 2 value. One is x1, another is x2, right? And if these 2 linear equations can be expressed in terms of matrix, so matrix A x equals to b, matrix A x equals to b. Okay, where A is nothing but the matrix 5 6 4 7. X is nothing but a column matrix x1 x2, and B is another matrix of 3 8. Okay, है ना? So there is 2 unknown x1 and x2. There is 2 unknown x1 and x2. There is 2 unknown x1 and x2. So if two linear equations have a two unknowns, it means we get two roots of this of the given linear equations. Similarly, if a matrix is 2 cross 2 matrix, then we get two eigen values only. If a matrix is have a order 2 cross 2, then this matrix have only two eigen values, because this matrix is formed from two linear equations having two unknown. Okay, so note down. If there have a two linear equations, with two unknown, then we get a 2 cross 2 matrix. We get 2 cross 2 matrix, and this matrix have two root or two eigenvalues, okay. There are two linear equations, and two linear equations have two unknowns. It means we get a matrix, and this matrix have only two eigenvalues, and these two eigenvalues is called root of these two linear equations. Okay, if we satisfy these two values, here and here, this equation number 1 and equation number 2 will be satisfied. Okay, first of all, check it. This is the matrix, and this matrix, first of all, this matrix, we are trying to find out eigenvalues of this matrix. And then satisfy these equations 1 and 2, and we have decided what is the final result of these expressions, or what is the final result of eigenvalues. What are the eigenvalues of these equations? What are the eigenvalues of this matrix? What are the eigenvalues of this matrix? So we use characteristic equations. Characteristics equation is nothing but a minus lambda equals to 0. It means 5 minus lambda equals to 6, 4, 7 minus lambda is equals to 0. Okay, is it clear? So now next we perform some basic algebra of determinant. So 5 minus lambda is equals to 7 minus lambda equals to 24 equals to 0. So it is equals to 35 minus 5 lambda minus 7 lambda plus lambda square minus 24 equals to 0. So lambda square minus 12 lambda plus 35 minus 24 equals to 0. Okay. Now lambda square minus 12 lambda is equals to 11, right? 11 प्लस 11 इक्वल्स टू 0 है ना? नो, plus 11 is equals to 0. So this is equals to lambda square 11 plus 1 lambda plus lambda equals to 0. Lambda square 11 lambda minus lambda plus 11 equals to 0. So take lambda, so lambda minus 11 minus 1, lambda minus 11 is equals to 0. So lambda minus 11, lambda minus 1 is equals to 0. Okay. So lambda minus 11 is equals to 0 and lambda minus 1 equals to 0. So lambda equals to 11 and lambda equals to 1. Okay. So what are the eigenvalues of this matrix? Is first was 1, 1 and 11. 1 and 11. So these two are the eigenvalues. These two are the eigenvalues of the given matrix. These two are the eigenvalues of this matrix. Okay. Next, what are the properties of eigenvalues? 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 These all properties are very important. Please remember all properties of eigenvalues. Properties of eigenvalues. Properties of eigenvalues. What are the properties of eigenvalues? A square matrix, first property is a square matrix A, square matrix A and its transpose and its transpose that is A transpose have same eigenvalue. It means same eigenvalue. Same eigenvalues. A matrix A and its transpose have the same eigenvalue. It means there is a matrix A. There is a matrix A. 5, 6, 4, 7, and its transpose matrix is 5, 6, 4, 7. These two matrices have the same eigenvalue 11 or 1. These two matrices have same eigenvalue. This matrix have a eigenvalue lambda equals to 1 and 11. Also, this matrix have a eigenvalue 1 and 11. These two matrices have same eigenvalue. So, it is very easy to calculate the eigenvalue of transpose of any matrix, right? So, it is very easy to calculate the eigenvalues of a transpose of a matrix. So, for calculations of eigenvalues of any transpose matrix, we are first of all calculate eigenvalues of the given matrix. You can calculate eigenvalues of given matrix. Okay, there is no necessary to calculate first of all calculate transpose of matrix and then calculate the eigenvalue. They are the same eigenvalue. So no need to calculate first transpose of this matrix and then the respective process to calculate the eigenvalues. So we are mainly calculate the eigenvalues of the matrix. No need to calculations of eigenvalues of transpose of any matrix. We are only calculate eigenvalues of matrix A. We are only calculate eigenvalues of matrix A because matrix A and transpose of this matrix have the same eigenvalue. This is the first properties. Second properties. Second properties. Sum of eigenvalues. Sum of eigenvalues. Sum of eigenvalues. Sum of eigenvalues of a matrix sum of eigenvalues lambda 1 plus lambda 2 plus lambda 3, lambda 1 plus lambda 2 plus lambda 3 and so on. Sum of eigenvalues of a matrix is called trace of a matrix. Okay, trace of matrix, trace of matrix. It means trace of A is nothing but lambda 1 plus lambda 2 plus lambda 3 and so on. Yeah, is it clear? Trace of a matrix is nothing but sum of eigenvalues. Sum of eigenvalues. Also, there is another definition of trace. Trace of a matrix is nothing but sum of diagonal elements. Okay, there is another definition of trace. There is another definition of trace. There is another definition of trace. There is another definitions of trace. There is another definitions of trace. Okay, trace of A is nothing but sum of diagonal element. Okay, sum of diagonal element, that is nothing but A11 plus A22 plus A33 and so on plus ANN. It's another definition of trace. Okay, so sum of diagonal element is nothing but sum of diagonal elements is nothing but sum of eigenvalues. So it means A11 plus A12 plus A33 and so on, ANN is equals to lambda 1 plus lambda 2 plus lambda 3 is equals to lambda n. It's very important. It is very important. Clear? So trace is nothing but sum of eigenvalues. Also, trace is nothing but sum of diagonal elements. So comparing these two definitions, we are get sum of eigenvalues is nothing but sum of diagonal elements. Okay, this is very important result. Next properties. Properties number 3. Product of eigenvalues of matrix A eigenvalues. Product of eigenvalues of matrix A is called determinant. Is called determinant of matrix A. Okay. So we are trying to find out determinant of a matrix. So it is very easy. Multiply all diagonal elements or multiply all eigenvalues. Multiply all eigenvalues. It means determinant of A, that is mod of A, is nothing but lambda 1, lambda 2, lambda 3 and so on lambda n. Okay. Multiply all eigenvalues, we get determinant of matrix. Determinant of matrix. Clear? So trace of a matrix is nothing but sum of eigenvalues. Determinant of a matrix is nothing but product of eigenvalues. Product of eigenvalues. These two important result. These two are very important results in matrix algebra. These two are very important result in matrix algebra. Okay. Trace is nothing but sum of eigenvalues and determinant of matrix is nothing but product of eigenvalues. Product of eigenvalues. Okay. Is it clear? Okay. Next, another properties. Properties number 4. If lambda 1, lambda 2, lambda 3 are eigenvalues of matrix A, then 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 are eigenvalues of inverse of A. Okay, inverse of A. So it is very easy. If there is a question, find out the eigenvalue of a matrix A, it is very easy. Then another question, find out the eigenvalue of inverse of this matrix. So it is also very easy. 1 by lambda, 1 by lambda, 1 by lambda 2, 1 by lambda 3 and 1 by lambda. Inverse of A, it means A inverse. है ना? Okay. So now I am trying to prove it. How can I prove it? If a matrix have a eigenvalue lambda 1, lambda 2, lambda 3, then this matrix have a inverse forms and that matrix have a eigenvalue 1 by lambda 1, 1 by lambda 2, 1 by lambda 3. How can I prove it? How can I prove it? Okay. Let us take a heading. Let us take a heading. Questions. If lambda be an eigenvalue of a matrix, if lambda be an eigenvalue of a matrix A, then so that 1 by lambda or lambda inverse, these two are very similar. 1 by lambda or lambda inverse is an eigenvalue, is an eigenvalue, is an eigenvalue of A inverse. Okay, A inverse. It means a lambda, if lambda is an eigenvalue of matrix A, then 1 by lambda or lambda inverse is an eigenvalue of inverse of this matrix. Inverse of this matrix. So how can I prove it? Okay. So for use the eigenvalue equations, we use eigenvalue equations. A into x, A is matrix, x is unknown, equals to lambda into x. Lambda is eigenvalue. Here lambda is eigenvalue, x is unknown. Where A matrix, given matrix, S is unknown matrix, lambda is eigenvalue. Eigenvalue equations. Eigenvalue. This is the eigenvalue equations. X is unknown matrix or it is called eigenvectors. Unknown matrix or it is called eigenvectors. Eigenvectors we are already eigenvectors we are studying few moments later, right? Eigenvectors, matrix have a eigenvalue, hence it's also have a eigenvectors. This is eigenvectors. Okay, so now multiply with these equations A inverse. Now multiply with these equations from left side A inverse. Now multiply with these equations A inverse from left side. Okay, from left side. Now multiply with these equations A inverse from left side. Is it clear? So now A inverse A into x equals to lambda A inverse into x. Okay, so as we know, A inverse into A into x equals to lambda A inverse into x. है ना? A inverse A is nothing but identity matrix. A inverse A is nothing but identity matrix. X. Okay, so this is nothing but 1 upon lambda into x is equals to A inverse x. So it is equals to A inverse x equals to 1 upon lambda into x. So this is the eigenvalue equations of A inverse. है ना? This is an eigenvalue equations. This is an eigenvalue equations of A inverse So from eigenvalue equations we are very easily say A inverse have a eigenvalue 1 by lambda. And so hence A inverse have eigenvalue 1 by lambda. So matrix A have a eigenvalue lambda and its inverse matrix have a eigenvalue 1 by lambda. Is it clear? Okay. Fourth properties is complete. Now fifth properties. Fifth properties of eigenvalues. Fifth properties of eigenvalues. If lambda 1, lambda 2, lambda 3 are eigenvalues of matrix A, then eigenvalues of Ka, eigenvalues of Ka, where K is a scalar number each K lambda 1, K lambda 2, K lambda 3. Okay, I mean that is the example. A is nothing but 2, 3, 4, 6 and it's have a eigenvalue lambda equals to lambda 1 and lambda 2. Okay, now we are trying to find out the eigenvalues of 5A. What is the eigenvalues of 5A? What are the eigenvalues of 5A? 5 lambda 1 into 5 lambda 2. There is no need to calculate first 5A and then calculate the eigenvalues of this matrix, new matrix on 5A. There is no need. I mean 5A means 10, 15, 20, 30. So there is no need to calculate eigenvalue from this matrix. I only multiply 5 with the previous eigenvalue, So eigenvalues of this matrix is equals to 5 lambda 1 and 5 lambda 2. Is it clear? There is no need to calculate again eigenvalue for this new matrix. There is no need to calculate eigenvalues for new matrix. I only multiplied 5 with previous eigenvalues of previous matrix. Okay? Is it clear? Okay. Properties number 6. If lambda 1, lambda 2, lambda 3, I only mentions here 3 cross 3 or otherwise lambda n are eigenvalues of matrix A, then eigenvalue of
a to the power n, where n is integer, 2, 3, 4 and so on. A square, a cube, a to the power 4, a to the power 5. What are the eigenvalues of this matrix? Then eigenvalues of a to the power n is lambda 1 whole to the power n, lambda 2 whole to the power n, lambda 3 whole to the power n. That is, take m is equals to 1, 2, 3, 4, and so that's why lambda n whole to the power n. Is it clear? Is it clear? The properties number 6 of eigenvalues. Okay. Clear? Okay. First of all, let us take a special type of matrix. First of all, we are taking properties number 7. It's very important for competitive exam purpose. It's very important. It's very important for competitive exam purpose. It is very important. First of all, we take a special type of matrix. Okay. We take a special type of matrix. 1, 2, 3. Okay. 2, 4, 6, 3, 6, 9. This is a one type of special type of matrix. 1, 2, 3, 2, 4, 6, 3, 6, 9. 1, 2, 3, 2, 4, 6, 3, 6, 9. 1, 2, 3, 2, 4, 6, 3, 6, 9. This is a special type of matrix. This is a special type of matrix. Okay. First of all, we are trying to understand the elements. Elements means 1, 2, 3, 2, 4, 6. First of all, we are trying to understand the elements. Elements are how these elements are basically formed. How can these elements are formed? Okay. We are the general form of matrix. We know the general form of matrix. A11. Okay. A12. A13. A21. A22. A23. A31. A32. A33. Yes or no? Here A11, it means one elements. We have pick one element, right? We pick one elements. We pick one elements. One elements. One elements, I means very general expressions of this matrix is nothing but matrix of Aij 3 cross 3 matrix. Is or no? I or j run from 1 to 3, j run from 1 to 3. I run from 1 to 3, j run from 1 to 3. Okay. Here I means ith number of row. I means ith number of row. J means jth number of column. Basically these elements are basically present ith number of row and jth number of column. No. First row, second column, 1 2 first no first row কলাম দাঁড়িয়ে থাকে না ith number of row jth number of column okay column means khamba দাঁড়িয়ে থাকে okay to check first of all here if we consider a11 elements is equals to 1 है ना a11 element is equals to 1 it means first row and first column is multiply each others 1 and 1 multiply and then get we these elements 1 1 first number of row second first number of column multiply with each others and this value is nothing but 1 similarly a12 is equals to 2 it means first row second column is multiplied with 2 in the same manners all elements are from jth number of row ith number of row jth number of column multiplied with ith number of row jth number of column each elements 2 this elements is nothing but a21 this element is nothing but a22 2 multiplied with 4 this element nothing but a23 this means 2 row number 2 and column number 3 multiplied with and this number is nothing but 6 so a matrix each element is formed by product of ith number of row and jth number of column है ना a matrix is formed whose each elements a matrix which is formed whose each elements are is nothing but the product of ith number of row and jth number of column this is a special type of matrix is it clear so how can I find out the eigenvalue of this type of matrix there's a trick also first of all we are find out the eigenvalue in very straightforward methods already learn it and then we trying to find trying to understand the trick behind this to find out the eigenvalues this trick only valid for this matrix what is the matrix this matrix whose elements are formed by product of ith number of row and jth number of column and okay this is the definitions a matrix whose elements are formed by product of ith number of row and jth number of column this is 9 it means 3 into 3 first 3 is for number of row and second 3 is for number of column okay it means positions of these elements are basically located at row number 3 and column number 3 and these 3 multiplied with each others and we get these elements so a matrix is formed by product of ith number of row and jth number of column so how can I find out first of all we we calculate the eigenvalues of this matrix in very straightforward manner, normal methods. Then we calculate in very in trick to calculate the eigenvalue of this matrix in trick, using trick. And tricks are very important for competitive exam purpose. Straightforward methods is very useful for semester purpose. Okay. Now trying to find out the eigenvalues of this matrix. Okay. So please remember this approach. A matrix is formed by the product of ith number of rows and jth number of columns. This is very important. Okay. So now we use characteristic equations. Use characteristics equations. Use characteristics equations. 1 minus lambda 2 3 2 4 minus lambda 6 3 6 9 minus lambda is equal to 0, है ना? Okay. So this is equals to 1 minus lambda 4 minus lambda 9 minus lambda minus 36 plus 2 18 minus 2 into 9 minus lambda plus 3 12 minus 3 into 4 minus lambda is equal to 0. Okay, please note down. Okay. 1 minus lambda is equals to 36 minus 4 lambda minus 9 lambda plus lambda square plus 36 plus 2 18 minus 18 plus 2 lambda plus 3 minus 12 plus 12 minus 12 plus 3 lambda equal to 0. 36 minus 36 cancel each others, 18 cancel each others, 12 cancel each others, है ना? Okay. So now 1 minus lambda into plus lambda square minus 13 lambda plus 4 lambda plus 9 lambda equal to 0. Yes or no? Complete? Complete? So okay, first is lambda square minus 13 lambda minus lambda cube plus 13 lambda square plus 13 lambda is equal to 0. Yes or no? Minus 13 lambda plus 13 lambda is cancel each others. Minus 13 lambda plus 13 lambda cancel each others. So plus lambda square minus lambda cube plus 13. Yeah, 13 or 14? Yeah, 14, no? Minus lambda cube plus 14 lambda square is equal to 0. Lambda square or 13 lambda square. So take lambda square is common. Take minus lambda square, take common. So lambda minus 14 equals to 0. So lambda square equals to 0. Lambda minus 14 equals to 0. So lambda equals to 0, 0. Lambda equals to 14. Okay. So what are the eigenvalues?
0 or 14?
Not 0, 0, 0, 14. 0, 0, 14. That is 2, 0. Same eigenvalue. We get same eigenvalue. So please remember. So a matrix. So there is a matrix whose elements are formed by product of ith number of row and jth number of column. This matrix have 2 zeros eigenvalues and 1 non-zeros eigenvalues. 2 zeros eigenvalues, 1 non-zeros eigenvalues. And non-zeros eigenvalues is nothing but 9 plus 4 plus 1 is 14. 9 plus 4 plus 1, it is nothing but sum of diagonal elements. It means trace of this matrix. Trace of this matrix. So what are the eigenvalues of this kind of matrix? Is nothing but 0, 0 and trace of this matrix. Trace of this matrix. Okay. It is 3 cross 3 matrix. That's why there is a two zeros eigenvalues. If it is 4 cross 4 matrix, then there is 3 zeros matrix, and last one is trace of this matrix. Trace of this matrix. There is no need to calculate what are the eigenvalues. What is the eigenvalues? So there is a special matrix. This is one type of special matrix. What is matrix? Each matrix are formed by the product of ith number of row and jth number of column. Please remember this properties. Okay. So as okay. So now we take a note and clarify all the concept regarding this matrix. Okay. So what are the eigenvalues? 0, 0 and 14. 14 is nothing but trace of this matrix. Yes or no? 14 is nothing but trace of this matrix. So let us take a note. This is very important. Let us take a note. It's important. It's very, very, very important. Okay. It is very, very important. A matrix whose elements are, it's nothing but product of nothing but product are nothing but product of ith number of row and jth number of column. A matrix whose elements are nothing but product of ith number of rows and jth number of columns, then its have eigenvalues are 0, 0, 0 trace of this matrix. Okay? Okay? First, if for 2 cross 2 matrix, if matrix is 2 cross 2, if matrix is 2 cross 2, then it have 1 0 matrix, 1 0 eigenvalue, and 1 non-zero eigenvalue. Yes or no? Second, if for 3 cross 3 matrix, 3 cross 3 matrix, then it have 2 0 eigenvalues, 2 zeros eigenvalue, 2 zeros eigenvalue, 2 zeros eigenvalues, and 1 non-zero eigenvalues. Non-zero means trace. Non-zero means trace. Non-zero means trace. Three, if 4 cross 4 matrix have a matrix, then it have 3 0 matrix, 0 eigenvalues, 3 zeros eigenvalues, and 1 non-zero eigenvalues. Is it clear? Is it clear? So there is a concept. What is the concept? What is a concept? There is a concept. Three cross 3 matrix, there are 2 zeros eigenvalues. Yes or no? 4 cross matrix, there are 3 zeros eigenvalues. 3 0 means 3 zeros. 3 zeros. Right? 3 zeros. So all eigenvalues are same. It means degenerate eigenvalues. We get degenerate eigenvalues. Degenerate eigenvalues. When all eigenvalues are same, then this one is non-degenerate. This all zeros are degenerate eigenvalues. Trace of this matrix is non-degenerate eigenvalues. So if a matrix have a order n cross n, then it have a n minus 1 degenerate eigenvalues and 1 non-degenerate eigenvalues. This is the questions for this matrix. This is the questions basically asked in competitive exam. If there are a n cross n matrix whose elements are basically from ith number of product of ith number of row and jth number of column, this matrix have a how many degenerate eigenvalues get? N minus 1. N minus 1. No, degenerate mean non-degenerate 1, non-degenerate 1, degenerate n minus 1. 4 means 4 minus 1, 3. 3 cross 3, it means 3 minus 1, 2. Okay, so what is the concept? For n cross n matrix, for n cross n matrix have n minus 1 degenerate eigenvalues, or eigenvalues are 0. N minus 1 zeros eigenvalue, n minus 1 zeros eigenvalues, or n minus 1 degenerate eigenvalues. Same. Eigenvalues is nothing but 0. Eigenvalue, all eigenvalues are 0. N minus 1 eigenvalues are 0. One eigenvalue is trace of this matrix. N minus 1 degenerate eigenvalues, or n minus 1 zero eigenvalue. Okay, n minus 1 degenerate eigenvalue or zero eigenvalue, and 1 non-degenerate eigenvalue. One non-degenerate eigenvalue, which is trace of this matrix. Yes or no? Trace of this matrix. Is it clear? Is it clear or not? Is it clear or not? So please remember this special type of matrix. Please remember this special type of matrix. Okay. Okay. Let us take this matrix have another approach. This matrix have another approach. Same matrix, 1, 2, 3, same matrix. Okay, this is properties number 7, right? Okay, next properties number 8. If lambda 1, lambda 2, lambda 3 and so on, lambda n are the eigenvalues, of matrix A, eigenvalues of matrix A, then eigenvalues of exponential A. Okay, eigenvalues of exponential A is nothing but e to the power lambda 1, e to the power lambda 2, e to the power lambda 3, and so on, e to the power lambda n. Is it clear? If lambda 1, lambda 2, lambda 3 are eigenvalues of a matrix A, then what are the eigenvalues of exponential A? Exponential A. Okay? Using these properties, we can establish a very important mathematical relations. It is also important for competitive exam purpose. Note down. Okay, this is also important for competitive exam purpose. It is also important determinant of e to the power a. We can find out. We are trying to find out determinant of exponential A matrix. There is first matrix A, then we find out exponential of this matrix, and then find out determinant of this matrix. How can I find out the determinant of exponential of matrix? It is important. How can I find out determinant of exponential of any matrix? Determinant of exponential of any matrix. Okay. So what is the meaning of determinant of any matrix? Product of eigenvalues. We are already know determinant of any matrix is nothing but product of eigenvalues. So it is equals to product of eigenvalue of exponential A. Product of eigenvalue of exponential A. So what are the eigenvalue of exponential A? If lambda 1, lambda 2, lambda 3 or lambda n is the eigenvalue of matrix A, then what are the eigenvalues of exponential A? Okay, product of eigenvalue. So e to the power lambda 1 into e to the power lambda 2 into e to the power lambda 3 and so on e to the power lambda n. So this is nothing but e to the power lambda 1 plus lambda 2 plus lambda 3 and so on plus lambda 1. So what is the meaning of this? Exponential lambda 1 plus lambda 2 plus lambda 3 total lambda n. What is the meaning of this? What is the meaning of this? Lambda 1, lambda 1 plus lambda 2 plus lambda 3 plus lambda n. What is the meaning of this? Trace of this matrix. Trace of matrix A. So it means e to the power trace of A. Okay. So determinant of exponential A, it means x trace of it. It's very easy. So determinant of exponential A is nothing but e to the power trace of A. Huh? Okay, let us take an example. This question is asked in TIFR 2018. The matrix, okay, the matrix 1, 0, 1 second. Yeah, I can get matrix. Yeah. If a 2 cross 2 matrix, if a 2 cross 2 matrix M is given by M is equal to 1 minus I upon root 2 1 plus I upon root 2 0. If a 2 cross 2 matrix is given by 1 minus I upon root 2 1 plus I upon root 2 and 0. Okay. Then find determinant of exponential m is what? Option A e, option B e square, option C 2i sine root 2, option D exponential minus 2 root 2. What is the answer? Determinant of exponential m, it means we can use these expressions. We can use these expressions. So determinant of exponential m is equals to e to the power trace of m. Trace of m, it means sum of diagonal element. Sum of diagonal element 1 plus 0, it means e to the power 1. So E. So answer is option A. It's very easy. Okay. Is it clear? Next step, we are trying to find out eigenvectors of a matrix. Next case, let's take a heading eigenvectors. How to calculate eigenvectors of a matrix? How to calculate eigenvector of a matrix. How to calculate eigenvectors of a matrix? So to find out the eigenvector of a matrix, first of all, we calculate eigenvalues. For each eigenvalue, we get one eigenvectors. If we get 3 eigenvalues, then we get 3 eigenvectors. Okay? If we get 2 eigenvalues, this matrix have 2 eigenvectors. Okay, so for calculating eigenvectors, there is a first need to calculate eigenvalue of the given matrix. So for
How can I calculate eigenvalues of a matrix? We are already know. Using the previous concept, we are calculate again eigenvectors of this matrix. So for calculate eigenvectors of a matrix, we use eigenvalue equations of matrix. Eigenvalue equations of matrix. So for calculations, eigenvector of a matrix. So for eigenvalue, calculation of eigenvalue, we use characteristics equations. Yeah. For calculations of eigenvalue, we use characteristics equations of matrix, and for calculations of eigenvectors, we use eigenvalue equations. So these two are very important, and please be clear these two concepts. For calculations eigenvalue, we use characteristics equations. Why it is called characteristics equations? Because a minus lambda I is equals to 0 is not equals to 0, it is called characteristics polynomial. It is called characteristics polynomial. If it is equals to 0, then it is called characteristics equations. So if any examiner asks, write down the characteristics polynomial of the matrix. So mod of lambda a minus lambda I, this is characteristics polynomial. And if any examiner asks, write down characteristics equations of this matrix, then mod of a minus lambda is equals to 0. So there is a basic difference: characteristics polynomials and characteristics equations. Okay, these are the two basic difference between characteristics polynomials as well as characteristics equations. Characteristics polynomials, it means a minus lambda I, it is called characteristics polynomial. Strict polynomial, okay, or a minus lambda is equals to 0 is called characteristics equations. I mod of a minus not mod, determinant of a minus lambda I is called characteristics polynomial, and determinant of a minus lambda is equals to 0 is called characteristics equations. Characteristics equations. So please clear this 2 point. Okay. But here to calculate eigenvectors of a matrix, we use eigenvalue equations. Eigenvalue equations. Eigenvalue equations. So for calculations eigenvector of a matrix, we use eigenvalue equations, that is basically ax is equals to lambda x. Okay, where A is a matrix, X is a vectors, eigenvectors. We are trying to find out. Basically, it means A, x1, x2, and so on into lambda x1, x2, and so on. Okay. If the matrix is 2 cross 2, then entries are basically x1 and x2. If this matrix A is 2 cross 2, so there are 2 entries. Okay, x1 and x2. If matrix A is 3 cross 3, if the matrix A is 3 cross 3, there are 3 entries: x1, x2, and x3. It means 3 unknown. If this is 4 cross 4 matrix, there is 4 unknown, 4 entries: x1, x2, x3, x4.
Is it clear? So this is the this is the eigenvalue equations, and here lambda have a different value. For lambda equals to lambda 1 characteristics equations, lambda equals to 2. Yeah. For each lambda, we get 3 values, 3 unknowns. Yeah, it is necessary. For each lambda, we can calculate. For each lambda, we always calculate all entries values. What is the value of x1? What is the value of x2? What is the value of x3, and so on. For each case, we are calculate this value of these entries. Basically, this value of is unknown. What is the value of x1? What is the value of x2? What is the value of x3? And then these values are very important here. What is the value of x1, x2, x3? And then we get the vectors, eigenvector corresponding this eigen value lambda. Okay. So already take a matrix. Already we have taken a matrix. Already take a matrix. Already we are taking a matrix and calculate eigenvalues. Please mention what is the matrix. Any matrix, any 2 cross 2 matrix. We are already 2, 3, 4, 6. Okay, 2, 3, 4, 6. Is it right? 2 cross 2 matrix. This matrix have a 2 eigenvalues. First eigenvalue is 1, second eigenvalue is 11, right? This matrix have a 2 eigenvalues. Lambda 1 equals to 1, lambda 2 equals to 1. For these 2 eigenvalues, we get 2 eigenvectors here. Is it right or wrong?
5, 6, 4, 7.
2, 3, 4, 6. What is the eigenvalue? Okay, 5, 6, 4, 7. This is the matrix, and this corresponding this matrix we get eigenvalues. Lambda 1 equals to 1, lambda 2 equals to 11. Okay, is clear? For each eigenvalues we get 1 eigenvectors. For each eigenvalues we get 1 eigenvectors. 1 eigenvectors. For each eigenvalues we get only 1 eigenvectors. Each eigenvalues we get only 1 eigenvectors. There are 2 eigenvalues, it means we get 2 eigenvectors. Yeah. For each eigenvalue we get 1 eigenvectors. So how can I calculate eigenvectors? So for lambda 1, for lambda equals to 1, we use eigenvectors equations. A x 1x, yes or no? Ax 1x, because lambda equals to 1. A means matrix form 5, 6, 4, 7. X means 2 entries, x1, x2. Is it clear or not? 1, x1, x2. Okay. In left hand side we get matrix multiplications. So 5x1 plus 6x2. Yeah. है ना? When two matrices are multiplied, then we get a matrix. Then another is 4x1 plus 7x2. Yeah. That is equals to is it? Yes or no? That is equals to 5x1 plus 6x2 equals to x1. So it is equals to 4x1 plus 6x2 equals to 0. This is equation number 1. And another is 4x1 plus 7x2 equals to x2. 4x1 plus 6x2 equals to 0. This is equation number 2. Here equation number 1 or equation number 2 are same. So we take any equations. As there is two equations are same, equation number 1 and equation number 2 are same. So we take anyone. Your choice. Anyone. So 4x1 plus 6x2 equals to 0. Okay. 6x2 equals to 4x1. 3x2 equals to 2x1, है ना? So x2 equals to minus 2 by 3 x1. Yes or no? So you take x1, if x1 equals to 1, x2 equals to minus 2 by 3. If x1 equals to 1, x2 equals to minus 2 by 3. Okay? Okay? So x1 equals to 1, x2 equals to minus 2 by 3. So what is the eigenvector corresponding this eigenvalue? So now eigenvectors x equals to 1 minus 2 by 3. Okay? This is the eigenvectors corresponding this eigenvalue. Is it clear? No, that's two eigenvalues means two eigenvectors. No. Lambda equals to 11. For lambda 1 equals to 1, we get only one eigenvectors. Then again we calculate lambda 2 equals to 11, another eigenvectors. For lambda 2 equals to 11, for 11, ax equals to 11x. Okay, a means 5 6 4 7, x1 11x1 11x2. Okay, yes or no? So this is nothing but 5x1 plus 6x2. Okay, 4x1 plus 7x2 equals to 11x1, 11x2. So now comparing these two equations, two matrix. So 5x1 plus 6x2 equals to 11x1. That is equals to minus 6x1 plus 6x2 equals to 0. This is equation number 1. 4x1 plus 7x2 equals to 11x2. 4x1 minus 4x2 equals to 0.
Again, these two equations is same. Yes or no? Minus 6x1 plus 6x2. If we take minus 6 common, same equations. Yes or no? These two equations again same. Again we take any one. Again we take any one.
So 4x1 minus 4x2 equals to 0. So 4x1 equals to 4x2. So x1 equals to x2. It means x2 equals to, if x2 equals to 1, x1 equals to 1. Okay.
So what is the eigenvectors?
x2 समान 1 1.
This is the eigenvectors corresponding lambda 2 equals to 11. Okay. These are the two eigenvectors. These are the two eigenvectors. But there is a question. Why you always take x2 equals to 1, x1 equals to 1? There is a question. We are always take x2 equals to 1, x2 equals to 3, 4, 6. Why you are not taking? Yeah. x2 equals to 2, 3, 4, 5, 6. Why here not taking? Always taking x2 equals to 1. In previous case, let us take 1. Why taking? What is the previous case? Please tell me. Previous relations. x1 equals to?
x2 equals to minus 2 by 3 x1.
Okay. This is the expressions. And present expressions is x1 equals to x2, right?
Here we always take x2 equals to 1 or x1 equals to 1, any 1. Why? If we take x1 equals to k, any value, okay?
If x1 equals to k,
K is any value, 1, 2, 3, 4 and so on, any value. So what is the value of x2?
minus 2 upon 3k, okay?
So now eigenvector
x1 equals to k minus 2/3 k,
okay? Then it is not a normalized eigenvectors. It is not a normalized eigenvectors. It is not a normalized eigenvectors. So for normalizations, what can I do? What can I do? x1 equals to 1 under root under k whole square, 2 by 3 k whole square, k minus 2 by 3k. Okay? Okay.
So x1 equals to 1 upon k square upon 4/9 k square. Yes or no? K minus 2/3 k root under 13 k square upon 9. Yes or no? K minus 2/3 k. So 3 upon root 13 into k minus 2/3 k. Okay, so now the expressions become 3/√3 minus 3/√13 is a normalized eigenvector. Yes or no? So there is any effect on k? Any effect on k? K 1, 2, 3, 4, there is no value. These are normalized eigenvectors. This is the normalized eigenvectors. In previous we get 1 minus 2/√3. If we normalized, then we get this value. Already in previous we get x1 equals to 1 minus 2/√3. If we normalized it, we get same value. Yes or no? Same value. So if we take 1, 2, 3, 4, there is no variations, no effect on this result. Okay, that's why we always take simple value 1. What is the reason behind that? If we take x1, x2 is any value, if we take x2 equals to 1 or x2 equals to 2 or x2 equals to 3, there is no effect on its normalized eigenvectors. If we take x2 equals to 2, then x1 equals to 2, then 2, 2. After normalized, we get 1, 1. No effect on this. No effect on normalized eigenvectors. That's why we always take simple value 1, 1, 1. Simple value. Is it clear? Why we take x2 equals to simple value 1? Because after normalizations, okay, please verify for another case. Please verify. For second case, x2 equals to x1. If we take x1 equals to k, x2 equals to again k is any value. K equals to any value 1, 2, 3 and so on. K equals to 1 any value 1, 2, 3 and so on. If we take any value, so eigenvector k or k. Okay, after normalizations, x2 equals to root under k square plus k square, k और k है ना, so that is equals to 2k square, k और k, that is equals to 1/√2 into k और k. So k cancel each others, so that is equals to 1/√2. Yes or no? Please check. After please normalize it. Same value we get. Huh? So there is no effect on normalized eigenvectors. Okay. So we always take x2 or x1 is equals to 1. x1 or x2 equals to 1. Always take. If we take 2, after normalized, it already we get 1. है ना? So there is no effect on its eigenvectors after normalizations. After normalizations, there is no effect. If we take any student x1 equals to take 2, any other student take x2 equals to 3. But after normalizations, we get same eigenvectors. There is no effect. There is no effect on eigenvectors. Okay. Any student take x1 equals to 1. After normalizations, we get same eigenvectors. Any student take x1 equals to 100. And after normalizations, we get same eigenvectors. So no, don't worry about it. Which value we are taking, x2 equals to 2, x2 equals to 3, x2 equals to 4, there is no worry. We always take a simple numerical number 1 and then normalized eigenvectors. We take a 1 and calculate eigenvectors and normalize it. Always. So in this way, we always calculate eigenvectors of any matrix, any order matrix, 2 cross 2 matrix or 3 cross 3 matrix. So first of all, we calculate eigenvalues and using eigenvalue equations for each eigenvalues. Using eigenvalue equations for each eigenvalues, we calculate eigenvectors and eigenvectors, normalized eigenvectors. We always calculate normalized eigenvectors. Always calculate normalized eigenvectors. Okay. Always calculate normalized eigenvectors. Any problem? Okay. So next day we I think we have finished this matrix class. One topic is remain only, Cayley Hamilton theorems and diagonalizations of matrix and similarity transformations of matrix. So these 3 topics are mainly remaining. Remaining 3 topics are Cayley Hamiltonian theorem, second is diagonalizations, 3 is a similarity transformations. Okay. Similarity transformations. These 3 are important topics. Next day we are finish it. Next day we finish it. Okay.